Hello everyone. Welcome to the solution of LeetCode problem 872 named Leaf Similar Trees. In this problem, we are given two trees and we have to determine whether their leaves are arranged in a same sequence or not. So here, in the first example, the first tree has root 3 and the leaves are 6, 7, 4, 9 and 8. In the second tree has root 3 and the leaves are 6, 7, 4, 9 and 8. So here we can see that both of the sequence of leaves has the one sequence. So we can say that both of the tree is leaf sequence. So if it is, we have to return true. Otherwise, we have to simply return false. Now, I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, we have taken this example to solve this problem. Here, we will use the depth first search technique. Now, let's run our DFS function into the first tree. Now, here, the DFS call is in this position, which is 5. Now, in the DFS call, which is in this position, which is 6. So, 6 is a leaf node because it does not have any of the children. So, we have to simply add 6, and now we have to use a separator. Let's say it is hash. Now from this 6, we are going to 5, and from 5, the call is in the 2. Now it is in the 7. Now from 7, the call again traces back to the 2. Now again, it comes to the 4. So again, there is a separator, and it is a 4. So from 4, the DFS call will be go to the parents. From 2, it will be 5. From 3, 5, it will be 3. Now from 1, from 3, it will comes to 1. And from 1, the call will be in the DFS 9. Now similarly, from 9, the call will be go its parent. And now the call is in the 8. Now here from 8, the call will be go its parent 1. From 1, it will go to 3, and from 3, it will return back. So here, by applying the depth first search technique into the first tree, we have found this sequence of the leaf node. Similarly, you can run the DFS on the second tree, and you will also find this 6, this 7, this 4, this 9, and this 8 as a sequence. And we will apply the various separator. Let's say it is our hash in between them. Now we can see that both of the string is equal. So if both of the string is equal, we have to return true. Otherwise, we have to return false. Now the question is why we use this separator hash. Suppose let's assume, suppose it is the tree, the root is 1 and 2 children is 2 and 3. And here the root is 1 and its children is 23, which is the left children, but it does not have any of the right children. Now here, if we do not use the separator, this first tree value, all the leaf sequence will be 23, 2 and 3, and its second tree sequence will be 23. Here, if we do not use the hash or any of the separator, both of the value will equal, but this is not. Both of the tree is not equal, right? So here we are using the separator. So by using the separator in the first tree, it will become 2 hash 3, and using the separator in the second tree, it will become 23 hash. So here, these two string is not equal, so we have to return false. I hope you understood the algorithm and why we apply the depth first search technique and the separator in this problem. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named leafSimilar, which has two roots, root 1 and root 2, both of the tree as a parameter. Now, we are calling the defs function on the root 1 and the root 2 by using the string x and y. And here in the defs function, if the root is null, we have to simply return. Otherwise, if the root is a leaf node, that means it does not have any of the left and right children. We have to simply add the root value along with the separator hash. Finally, we have to recursively call the DFS into the left subtree and into the right subtree. After that, if both of the string x and y is equal, we have to return true. Otherwise, we have to simply return false. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.